Please, can you see my screen?
Yes, we can see your screen. You can go ahead.
It's up now, it's up.
All right, thank you. Okay, so my name is Oluwafemi Adeshogbon, like I said, and we'll be going through introduction to networking. First and foremost, I would like to say a big thank you to the organizer of and all the administrator of CyberSec event and the opportunity to take this particular training. It's a huge privilege, and I do not take that for granted. And also, I would love to say thank you for all the people participating. I mean, embarking on the journey of this IT world, right? So let's just jump right into it. So today we'll be looking at some basic things. I know that we don't have enough time to cover this, but as much as I really love to cover everything that is here, I will stop at some point if the time is not enough, and I will also like us to go into some practical section, right? So because networking is practical, it's more of the practical, right? If you understand the practical, it's very easy for you to catch up with the theories and all of that, right? So the first thing, introduction, like I said, my name is Oluwafemi Adeshogbon, and I have over 5 to 6 years experience in the IT world, and my first degree is in applied physics. I have a master's in applied physics from Lautech, finished 2011. I have a master's in IT from University of Lagos, finished that 2018. I'm currently rounding up another master program in the UK currently in MSc in cybersecurity also. I've worked with different companies. I've worked with Tech Expert, I've worked with AB, Access Bank, and some few other companies. I've worked in the capacity of a network engineer. I've worked in the capacity of a cloud engineer, specifically for Azure, Microsoft partner company. I've equally worked as IT security. My recent job was IT security. I led the team in AB Bank as IT security, lead IT security. And I entered the company as a junior IT security, promoted to normal IT security, then I led the company eventually. So it's been a lovely journey for me. I'm very interested in cybersecurity. So you can probably check my LinkedIn profile, Oluwafemi Adeshogbon, same name and same connection. You can connect from there. Now, computer network. So I hope, I just really wish that this can be an interactive section as much as I know that the noise will not allow us. So if there's any point in time you have to answer a question I ask, please just wave. When you wave, Sheila will call your name and then you can unmute your mic. That will save us a lot of front and back. So the idea is if I ask a question, you do the wave signal, emoji on Teams. Sheila will call whoever she pleases or founds first to answer the question. And then just like that. So the computer network. So basically, we are talking about the introduction to networking, and it's very important for us to understand what computer network is all about, right? I have here, computer network is a group of computer device nodes that use a set of common communication protocol over digital interconnections for the purpose of sharing resources located on or provided by the network nodes. So what am I talking about? So from the basis of networking, this is the first thing I understand about networking. If you understand the Roman Empire, you understand networking very well. And why did I say that? Because networking is all about building roads. So one thing that was peculiar to the Roman Empire then was because they were good in in building roads. They know how to, navigate, roads, and they had chariots, they have different things, So that was one thing that was peculiar about the Roman Empire then. And that is what networking is all about. The best part, the fastest part, the most secure part to move from a point A to point B. That is networking, right? Basically, that is networking. We can understand that networking is moving from point A to point B. Either you are moving from one node to another node, irrespective of the nodes, right? That is what networking is all about. So I'm going to take that definition again, maybe to make some sense to us. So a computer network is a group of computer or devices, or rather called nodes, that uses a set of common communication protocols, right, over digital interconnections. So the first thing there is the nodes. The second thing you have to understand is that communication protocols, right? We'll talk a bit about communication protocols. Okay, we have it right here. Communication protocols is a set of rules for exchanging information over a network. So what are nodes? Nodes of a computer network may include personal computer, server, networking hardware, or other specialized or general purpose hosts. So I'm looking for a name here. Okay. Kayode Bamidele have a computer, and Kayode Bamidele wants to send an information to Bolaji Sulaimon, right? And he has Bolaji Sulaimon happen to have a server or in an old system, just like a laptop, and Kayode has a server. So Kayode has some services on that server, and he wants to send one of his services to Bolaji, right? Those are nodes majorly, right? Then what is interconnection? The interconnection between nodes are formed from a broad spectrum of telecommunication network technology based on physically wired, optical, or wireless technology. So the medium at which you send the data or an information from Kayode to Bolaji, that medium is equally known as interconnections between both of them, right? The nodes are the guys, laptop and server, while the interconnection is the medium. And then the last one, the protocol, is a set of rules for exchanging information over a network. All of this will make a lot of sense as time goes on, but I need you to understand that basics so that you can understand what exactly a computer network is, right? So take note of the nodes, take note of interconnection, take note of protocol. I'll take that again. Nodes are server, networking, hardware, general purpose host, and also interconnections is the medium at which you transfer. It could be physical wired, it could be optical, it could be wireless, right? A communication protocol is a set of rules for exchanging information over the network, right? So this is a typical view of what this looks like, right? So wired network, this is a PC. I'm assuming these are the switch. This is the firewall. This is the internet. This is a router, other LAN, and all sort of things here. If you are new to networking, don't let this intimidate you. To make a lot of sense as time goes on. And if you are familiar to networking, I'm sure you understand what this is all about in the first place, right? You know what a printer is and all of that. This is a typically networking. All of these guys communicate to themselves one way or the other, right? This fiber optical network cable is an interconnections between them. So it's the medium at which they communicate, right? The medium at which they communicate. These are nodes, server, switch, PC, those are nodes. Then the protocol that they use to communicate are the rules and set rules on how they should communicate, right? For example, there's a rule on the road. When you see red, you stop. When you see amber, ready to move. Those are protocols, right? And if you break it, there will definitely be an accident and there are consequences to it. So that is that. And let me go to the next slide. So I have a very quick question. And if you have an answer for this, just wave your hand. Sheila will call you to, say what you think about this. So the question is, what are the advantage / uses of network? If you have one or two of it, just wave your hand and then Sheila will call you. Okay, I'm reading through the chat and I can see that somebody said it's breaking. Please, Sheila, at any point you can't hear me, let me know, please.
All right, shouting, I will. Who's raising their hand? Okay, Queen Kosi, can you hear you? Kosi, okay.
Hello. Hello.
Hi, Queen.
We can hear you, we can hear you.
We can hear you, Queen.
Advantages of or uses of network implies that it aids in efficient communication or exchange of data in a layman's understanding. Thank you.
Amazing. So it aids the communication. It aids the communication. You can't imagine if Queen is sending message to Dave and she has to go all the way, do you understand, to send a message, or walk all the way, right, to send a message. But what a network does is it aids that communication. So that's an amazing answer. I'll take one more before we continue with the training.
Bridget Sang, can we hear your answer, please?
Okay, my answer is it enables sharing of resources.
I'm sorry, I can't hear
barely
that.
hear you. Can you speak louder?
It enables sharing of resources.
Oh, good. I think I heard that. It enables sharing of resources, right? Yeah, another word for aiding. It enables sharing of resources. Well, that is about it. No matter how complex a network is, I can tell you for free that that is the essence of it, right? That is the essence of a network. Those are the advantage, those are the uses of a network. It saves us a lot of stress, right? So having said that, we'll be moving on from here, and we'll be having the networking devices. So we talk about the nodes, right? We say some things about the nodes. We say something about the medium at which they communicate, and then we say something about the protocols. So we'll be taking a closer gaze on the nodes, right? We have the NIC card, we have the repeater, we have the hub, we have the switch, we have the router, we have the firewall. Trust me, there are a lot of nodes. There's even no bridge here. I know a bridge is obsolete, but there are a lot of nodes, right? There are a lot of sophisticated nodes, but I'm staying within. I might not even talk about all of these, right? I'm just going to brush through all of them just so that you understand. And these are literally the things that you will have to work with on the basis, right? So if you understand this, you will do well, right? It's good to go. So the first one is the NIC card, right? What is an NIC card? It's used to physically connect host device to the network media. I'm sure most of us probably have seen this before or not. If you have not seen, can you see my mouse? Sheila, can you confirm that you can see my mouse?
I can. Your mouse is. Yeah, I can.
All right, let me see if I can find a pointer somehow. Just a minute. I hope I don't mess this up. Can you see a pointer somewhere around? A red pointer, kind of.
Yes, I can.
Okay. All right, that will work for me. So, can you see this port? I'm sure a lot of people, even if you have not seen the whole of an NIC card before, it's called network interface card. But I'm sure you have seen this spot before. This is the RJ45 you plug your cable to. Where you plug your RJ45 connector to. So I'm sure you must have seen this before. So this is the this is the device that allows your network, your PC, to be able to be connected to the network, right? So it's either this or a wireless, what's it called now? A wireless device installed on the system, right? So if you see this, just know that this is a card that is plugging into the motherboard, right? That enables networking, this system to communicate to a network or to a switch, as it were. So that is what that is all about, right? So it can also be peripheral device. NICs are sometimes called network adapters, right? Each one of them has a unique access control address, which is MAC address. We will get there. This address is used to control data communication for the host on the network, right? So the types of address that we have will probably go there by the course of this training. So this is an NIC. I'm dwelling more here because this is something that we can easily and see the code, the port there, and we understand that, oh, this is NIC, right? So the next one is a repeater. You really don't need to worry much about a repeater. So it's used to regenerate a signal, right? So basically, it just forward packets. It's not very intelligent, right? So you can do a personal research on repeaters, but you really don't need to worry more about it. Orbs are obsolete. Nobody see orbs anymore, right? Do you understand? Active orb concentrate host and also regenerate signal, just like a repeater, but for a cable, right? So orbs are really, really obsolete. You really don't need to worry more about orbs. But I mean, as it stands, you need to understand some of the nodes, right? Then a switch, come to a switch and you realize that there's no far, you can't go too far in networking. When you start anything that has to do with networking, before you know it, you are hearing a switch, a router. Those two devices are very, very important, right? Now, this is a typical, how many ports now? This is almost 48 ports or thereabouts, Cisco switch, right? Switches add more intelligence to data transfer management. So the difference between a switch and a hub is that a full duplex, you can communicate, you can send data and receive data at the same time. Send data and receive data at the same time on a switch. Hub, everybody will have to queue, right? So there's a lot of collision on hub, but when it comes to switches, everybody is fine. So a switch can read and learn a MAC address, right? While hub is just not so intelligent to do that. So they can determine if data should remain on LAN and transfer data only to the connection that needs it, right? There's something we call app. When we get to protocol, we'll probably see more about that. It's called address resolution protocol on a switch. So it's like backing when a broadcast is sent. When I send a broadcast from a device, I will take note of this and then probably do an example of what I'm talking about in a packet tracer. So let me just run with the theory so we can have some time for practical. I intend to rush through the theory within the first 1 hour, then the next 30 minutes take a couple of practical sections so you can see how these things work with the packet tracer. So by that, you can, find more passion and drive to learn more.
Okay, Femi, please, sorry to cut you.
Yes,
the
please.
attendance is up now. Please, you all should start filling. It's open now, please. Who is drawing on the screen? Bikonu. Please don't do this, please. Can you delete this thing if you can? And if you can't, just don't do it. Thank you.
How does someone get to draw on the screen? I don't understand. Okay, so as I was saying, that's the switch, right? And then now the router. The router is very, 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 very important. So one of the features of the router is the router has all the capability listed above, right? Like of a switch, and then can regenerate signals, concentrate multiple connections, convert data transmission format, and manage data transfer. They can also connect to a wide area network, which allows them to connect LANs that are separated by great distance. So a Cisco router, you can see a Cisco router, not necessarily a Cisco router, you can see a router as the name implies, it routes you, do you understand, to your destination. It's the one that knows the best path for you to get to your destination, right? That is what a router does. It takes you, your switch is normally on a LAN, a local area network within the house. But you see a router, it routes you out of your local area, out of your environment. So without a switch, without a router, you probably might not be able to, go beyond your local area network. Do you understand? So a router connects you to the wide area, to another, depending on the topology of your network, another branch, as it were, another state, country, to the internet, majorly, right? So that's the router. And then the firewall, as the security person, you must always think firewall in your network environment. So a firewall is a network device or software for controlling network security and access rule, right? So the major work of a firewall, how best can I put this? Have you ever seen movies? I'm sure most of us have seen Game of Thrones. Or which one is closer to it? Where you see people literally building walls high. Do you understand? And so that people do not penetrate their environment. And in the wall of the wall that they have built, there's an access point where it is only somebody that have the key that can come in. Do you understand? And then that is what a firewall, that is where it comes from. Do you understand? So you can't come into my network except you have, proved yourself, or you agree to some certain rules that are defined in the network. Those are access rules. So firewalls are inserted in connections between secure internet network and potential insecure external networks, such as the internet. So one of the first things you have to understand is the internet there is insecure. There's a lot of drawing going on the board. I don't know.
Who is doing this now? Who is doing this, for goodness sake? Who is doing this? Can you just erase this thing you did, please? Femi, please kindly hold on. Everybody check their screen. Erase it, please.
It could be a mistake. Please just.
It's getting worse.
Yes, I can see that.
Oh my God.
It's all right. Let's not waste
It's all
time.
right, Femi, you can just go on. It's all right. It's fine. We will try to manage it like that. It's just that we are recording this
Yes,
session.
now.
It's going to be used for subsequent lectures, and this is very terrible. Please, let's work on this. Femi, sorry for this.
Yeah, it's all right.
Please continue. Yes.
So we just manage through this. Whoever is doing this, if you can. Oh.
Hey. Please see, when you click on your biro button bar, there is an eraser that is supposed to come out. Use the eraser and erase everything.
I think I can do something from here too.
Okay, fine. Thank you very much. Good. Thank you. Femi, you can go on. It's gone.
All right. So, what was I saying? The vital role firewall plays in network security grows in parallel with the constant increase in cyber attack. Think firewall. I know this is an elementary course, but please think firewall in your network. It's very important. Now we spoke about the NIC, the repeater, the hub, the switch, the router, and the firewall. If you have a question, you can note them down. By the end of the section, we can look at all of these questions. Now, the next thing we want to talk about is the media. Don't forget, we have explained what a network is. I'm trying to do a recap. A network has to do with nodes. The interconnection and the protocols. So the node is what we just spoke about. We have hub, we have switch, we have NIC, which is literally your system, a network card on your system. We have router, we have firewall. And then now we are talking about the interconnection, which is the network media, the means at which a data, a packet, and information is being transferred, right? So the function of the media is to carry a flow of information through a local area network. So there are two means, the wired media and then the wireless media. So the wired media, a widely adopted family that uses copper and fiber media in local area network technology, are collectively known as Ethernet, right? So there's copper cable and then there's fiber optics. Under the copper cable, we have coaxial cables, shielded twisted pair, unshielded twisted pair, right? So we'll take a look at them. Then we have the fiber optics. Then we have the wireless. Might not be able to go deep in the wireless because it might be a bit beyond the scope of this particular training, but we'll make a touch on the rest. Now this is the copper cable, right? This is the copper cable, and the most common, easiest, quick, cheap. Do you understand? But people mostly don't use this again, right? People mostly don't use it again. So the disadvantage of sending data over copper wire is that the further the signal travels, the weaker it becomes. How do I need a major example of this. Have you seen your olden days antenna? You know that round stuff that goes to the back of a TV? That's a typical
Yes, sir.
That's a typical copper cable. There's thin net and there's the thick net. If you notice, I remember when I was growing up, you see this long stride that is out. I remember one time like that, the mouth of our TV was shaking, right? And it was not getting the right channel that we want. And I realized that it has broken. I've always been the engineer in our house. So that's how I shop it to. I just cut it and brought out that stuff there. I didn't know that there were strands of, I don't know, they just wrap something behind it. So I was thinking that once this mouth can touch the inner part of the TV, everything will be fine. That's how everything spoils. So unfortunately, I have to face my dad. And I was given the beating of my life. Do you understand? So I could tell basically that this is what a copper cable is. So while growing up, when I learned about this, I could not forget the incident and I knew what the cable was all about, right? That's just by the side. Then we have the coaxial cable too, and it can run long distance than twisted pair cable, right? Speed 10 to 100 meter per second, cost inexpensive, media and connector size medium, maximum cable length 500 meters. Now the shielded twisted pair is also a copper wire, and what it does that is different from the next one, the unshielded twisted pair. I will explain that. They are the same thing, but the difference between these two, right? They are copper. The difference between these two is that, and they are both, one is shielded, one is not shielded, right? But they are both copper, do you understand? And they are both twisted pairs. Now, the reason why they are twisted is because of the electromagnetic wave. And this is beyond your scope. Don't worry, right? For some of us that have physics backgrounds, you will understand what it means when signals is traveling on a straight line. There is always an interference. So that's why they shield it, so that there won't be interference. And that's why they twist it. And then to make it much more better, when you shield it, do you understand? It goes a better way, right? So there is, this one is shielded, 0 to 100 meter per second. cost is moderate, medium to large, cable length is 100 meters, and then the UTP, this is the most common one that you will see, right? Protect the copper wire from physical damage. This is it, the outer jacket. This protects the twisted pair. Yes, this is it, protect the signal from interference. So electrically isolate wire from each other than identifies each pair. Do you understand? Color-coded plastic insulation. So I'm not going to go into the depth of how you make this connection. If you have seen a crimper before, all of this goes to the back of a connector called RJ45 connector, and there's a way you will connect it, right? I don't know it often, don't bother if you can do your research on it, but I've found myself clipping cables, and I've realized that it is when you are doing it continuously that you stay there. You might not eventually crimp a cable in your life. Do you understand? It's not a technical wherever. So, but if you want to know how to do that, you can buy a crimper, buy a cable, and then buy some connector, and then have a RJ45 cable to yourself. Then you can go on, which I know there's stripe brown and brown, stripe blue and blue, stripe green and green, stripe orange and orange. So there's a way all of this goes into there are 8 of them goes into the connector. The connector has 8 mouths. They plug it in and then you crimp it in. All right. Now, the last one is the fiber optic cable. This one is very, very amazing because this is the future. This one works at the frequency of light, right? The frequency of light, you know what that means? That means this one can travel a long distance. Do you understand? And at the speed of light. Long distance at the speed of light. It's like a glass. Speed of light, again, is 2.3 something times 10 raised to the power something. You can do the Google. You can calculate that. And this one does not have room for electromagnetic noise. There is no interference in this, right? But it is very, very expensive. So that's why you see most network telecommunications running fiber optics all around. It's only fiber optics you can run in a city. Do you understand? So to have a wired network, that's why they have it all around, and then it's a major source of communication. I've heard about communications from the Western world to Nigeria through the ocean, the Atlantic Ocean, and I heard about how that Glo is the major guy that have access to it. They run it as far as running this thing through the oceans that connecting the world, and it's fiber optics. So that's how strong it is, right? And then how reliable it is. Take note of your question. If you have question, you can ask me later. Now, we've talked about the nodes. We've talked about the medium at which they transfer. And then the one thing I didn't add to this slide is the wireless. Of course, you know what wireless is, and there are different types of wireless network, right? Starting from your Bluetooth to your hotspots, to your WAN, your Wi-Fi, right? When you have a modem, you're connecting to wirelessly. Do you understand? All of that, those are wireless to a point-to-point broadband, right? Wavelengths, different means of wireless. They are very, 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 they are very, very prone to attack. Do you understand? A wired network is always very secure than a wireless network. Do you understand? Because anybody can listen. Do you understand? They are majorly prone to attacks, right? So, but I mean, we can't do without wireless because there's some distance we can't travel to by ourselves, and running a wire there might be too expensive, as it were. There are security measures in wireless too, right? That people are, but that is one loophole. So that's wireless on a. So types of network. We'll talk about protocol in a bit, but types of network. personal area network, local area network, campus area network, metropolitan area network, wide area network, peer-to-peer area network. Take note of this. We will do some practical on it. We will probably build a peer-to-peer network and do a local area network, right? The personal area network is like my home network, right? I just decided to get a switch in my home and connect, or not necessarily a switch. I decided to buy a Wi-Fi in my home that can connect to a 3 device, and then the Wi-Fi has like, for example, let me show you something that I have here. I don't know if you can, let me confirm if anyone can see me. So this is Vodafone, right? And it is 5G. It is 5G, it's unlimited. This is my personal area network. This can connect up to 32 devices. This is connecting to my laptop right now. That's what I'm using for the meeting. This is also connecting to my phone right here. Okay. And my wife's laptop too uses this, and our phone uses this, right? So as it were, we have a personal area network. So that's what that means. We have a personal area network. It doesn't mean it is just personal, right? It can be in any kind of topology, but I'm not sure I'm covering topology in this slide. I can't remember, but I'll see if I'm doing topology here. See, that's personal area network. I just thought to mention that because it's not part of the slide. I won't talk about all of this. You can do a personal research on it. I think I have local area network there. What is campus area network? Campus area network is to majorly look at Unilag, for example, or your school. Do you understand? The department can communicate to another department and communicate to the library. Do you understand that? All of that. So there's a network within the campus, right? That's a campus area network. A metropolitan area network is majorly a city network. Why a wide area network is when you have a branch here and you have another branch in another environment entirely, right? You have a branch in Nigeria, you have another branch in Ghana, West Africa, and you have another branch even all the way in the UK, Europe. Do you understand? So that's a wide area network. You understand? They are complex as they become wider, they become more complex. As I said, the personal area network was easy to build. I mean, all I need to just do is to connect via Wi-Fi. Do you understand? And they set a password and all of that. Local area network is relatively easy to, right? But that's where to start from. Then the peer-to-peer is when I connect two laptops together and I'm sending something. A peer-to-peer is when it could also be when you're connecting via you're trying to get the data from somebody with Bluetooth, or what's this thing called now? Xender. Xender is so powerful that it takes your Wi-Fi capacity and just drag data. It's better than Bluetooth. That's a peer-to-peer, right? So I have local area network here because this is very important for you to note. I've literally talked about this. Do you understand? So a means of communication within 2 or 3 devices, right? So it's evolved and has been significant improvement in regards to speed and efficiency, right? The medium at which you used to talk, it could be a fiber optics, it could be a Cat5 cable. A Cat5 cable is category 5 of the unshielded twisted pair cable that we spoke about, right? A LAN cable. Most of the time people call it a LAN cable, local area network cable, right? Connecting 2 or 3 devices with a switch with 1 or 2 topologies that you prefer, right? That is a local area network. This is a messed up in this slide. So I don't have topology here, but I'll talk briefly on topology before I talk about network models. And network models majorly is where the protocol comes in, right? So what is topology, network topology? Network topology is the way you want to connect your network, right? So majorly there is bus topology, there is star topology, there's mesh topology. There is also hybrid topology. So what does this mean? This means that I'm connecting. I'll talk about the topology when I'm doing the practical section. It's more easier, so you can see what I'm talking about rather than having it in an abstract view in your head. So let's talk about the OSI model, network models. Before we go, I'd like to ask one question just to know that everybody are on the same page with me. Okay, I'm reading through the chat. Doing this purposely just to know that we're on the same point, on the same page rather. Okay, so what question do I have? What is the difference between a node and a network media? And then mention 2 examples of nodes and 2 examples of network media. That's my question. What is the difference between a node and network media? Mention 2 examples respectively. So Sheila, if you see any hands up, please kindly call on to any one of them. I can't see any hands up. Is it that people? Okay, there's Wahab. Please, if you see any hands up, please.
Okay, I'm trying to check whose hands are up, whose hands are up. Okay, Wahab, for now. I think that's the person. Wahab, you can answer.
Okay. A node is an end device. Like you have your computers, like printer, IP phones. These are nodes. Then when you're talking about your media, your network media, we are talking about your means of connection. What do you use in connecting the medium through which you connect 2 or more computers together? Like you talk about this wire now, copper wire. Then we'll talk about wireless when you are using electromagnetic connection. Then you talk about optic fiber. So okay. That is the difference between the 2.
Thank you, Wahab. Thank you so much, Wahab. That's amazing. That's a recap. I love that. I love the fact that you mentioned IPv4, you mentioned a printer to be a node, and you equally mentioned wireless and the wire network, fiber optics as a medium. So I think Alexandra or somebody waved and the person drop back his or hands. Do you have any contribution? Doesn't matter if you are saying what Wahab have said, but do you have any contribution, please? Any more persons?
I'm waiting. Okay, IB Tech. Who is that? IB Tech. Okay, can we hear you?
Okay. Just like what I have said, a node nodes are just end devices. It could be personal computers, could be even the network devices itself, routers and switches are also a node.
Yeah.
They're also nodes. Yeah. They're also nodes. Then the media, just like what I have said, is still all of the things you said are right. I'm gonna stick with that for the today.
Thank you, IB. That's what it is. So I just want to be sure that we're on the same page. So let's go to the network models. This is where the protocol comes in, the rules that you have to use to communicate. And there's a model. I don't know if anybody have heard about the ISO, Institute for Standardization Organization, blah, blah, blah. Do you understand? I'm sure everybody knows about ISO 27001, ISMS, Information Security Management System. So they are the one that came about this OSM model too. These guys, I don't even understand. I heard they are in Switzerland or something. They are really, really dictating a lot of things. But for conformity, this is very important. So they have decided to break down all the levels of communication between one device to another level, to another device. They broke it together and then set some protocols that can work within them. This is where it gets complex, and this is where people get confused. What is the meaning of all of this and all of that, right? So network model, OSI model, right? There's also another one. I won't dwell more on that. Because I think OSI model won against the other one, as much as they make reference to it. It's the DoD, Department of Defense.
Femi, your voice is breaking.
Can you hear me clearly now?
Yes, it's better.
Yeah. So the DoD, Department of Defense, have another one. I think that one just made application, presentation, and section into one, and then have transport network, and then made data link and physical layer into one. So it has just 4 layers. But we'll be talking about OSI. If you understand OSI, DoD will be very easy for you to understand. So there are 7 layers in OSI model, and then there are different acronyms that I've seen. I tried a lot of acronyms. I remember back in the days, 2010, that I was trying to, I was interested in networking and all of that. I tried different acronyms for this thing. Don't bother yourself. Just do a Google search, OSI model. If you forget any other one there, you'll see it there, the arrangement. But with time, as you walk in the network space, it won't be hard for you to know which section is this section. Do you understand? Because it's a subset of the other, right? So the first one is the physical layer, the data link layer, the network layer, the transport layer, the section layer, the presentation layer, and the application layer. All of these have their own role and protocols that run in it. So let's try as much as possible to see what we can get. Tasks involved in sending a letter. Now, there's someone sending a letter. The letter is written, put in an envelope, and dropped in the mailbox. The letter is carried from the mailbox to the post office. The letter is delivered to a carrier by the post office. Now, higher level, middle level, and lower level. Now, the sender, right, then after doing this, the receiver is about to get the parcel. The letter is delivered from the courier to the post office. The letter is carried from the post office to the mailbox. The letter is picked up, removed from the envelope, and read. Does that make any sense to you? Right? This is literally what you would do, sending a letter. Literally. And this thing also applies to the OSI model when you want to communicate from one device to another device, right? The OSI model, established in 1947. Yeah, the International Standard Organization is a multinational body dedicated to worldwide agreement on international standards. They are leading that space. And ISO is the Open System Interconnection. That is the full meaning of OSI. Open System Interconnection Model is the standard that covers all aspects of network communication from ISO. It was first introduced in the late 70s, right? Sorry, in 1970s, in the early 70s rather. So that is OSI model. Don't mistake OSI model to ISO. ISO is the body. The model is OSI, which is the Open System Interconnection, right? We've said a lot about this already, the layered architecture. Now, the layered architecture, a layered model, each layer performs a subset of the required communication function. Each layer relies on the next lower layer to perform more primitive functions. Each layer provides service to the next higher level layer, right? Changes in one layer should not require changes in another layer. The process on each machine at a given layer are called peer-to-peer process. Peer-to-peer process. Communication must move downward through the layer on the sending device, over the communication channel, and upward to the receiving device. So this is what that means. You can see that the letter is sent downward, and later upward. Do you understand? That is the same thing. There's a better diagram that shows this. We'll get there. Let me run through this particular one. So at the receiving device, the message is unwrapped layer by layer, with each process receiving and removing the data meant for it. The passing of the data and network information down through the layer of the sending device and back up through the layer of the receiving device is made possible by interface between each peer and adjacent layer. Interface defines what information and services a layer must provide for the layer above it. Now, this is what this means, right? Application layer send the data, presentation, section, transport, network, right? Physical is communicating to physical. Do you understand? Now, when you send the data from, let me start from transport to network, is adding, for example, now the protocols in transport is UDP or TCP. Do you understand? UDP is TCP is transfer control protocol. It's secure. UDP is user data protocol or something. It's not secure. Do you understand? So when you send a communication from transport to network, I've made a decision on transport that this packet is going to be TCP, right? Then when I send it to the network, I've communicated to the network that it's going to be TCP. For the networks this with IP addressing. Data link this with MAC addressing. Physical layer did with bits and bytes. Do you understand? That is what the language of wires understand. Do you understand? Bits and bytes, zeros and ones. When you get to physical layer on the system sending, the system receiving gets the bits and ones. Then this one unwraps the MAC address. Then this one unwraps the network, the IP address. Then this guy in transport layer check what medium is trying to use to transfer. Is it TCP or UDP? If it is TCP, now there's always a communication within these two guys. If you notice, there's peer-to-peer. Do you understand? This guy, we have to communicate to this guy. They have to communicate to each other. I don't know how best to explain this. You probably have to do a couple of videos on it on yourself. This is an elementary class, and hopefully the practical section will make more sense to it. Hopefully, do you understand? But don't be bored about this. Don't let this bore you. So section layer 2 is a peer-to-peer, presentation is a peer-to-peer, application is a peer-to-peer. I'll run through something and see if you understand, and I'll tell you as this is broken down all together. Okay, so what do I have here? An exchange using the OSI model. This is zeros and ones. This is this does not make a lot of sense, right? It only makes a lot of sense to this guy here, the physical layer, right? Transmission medium, either wireless or wired. It goes through the wire, it goes to this medium, then send the exact thing. If you look at this, if you look at what is on the left side, the same time as what is on the right side. The exact thing here is what is taken here. Do you understand? And these are bits. Layer 2, which is data link, deals with frame. Layer 3, which is network, deals with packets. So let's talk about the physical layer. The physical layer is responsible for movement of individual bits from one hop or node to the next, right? So we're talking about node. The movement between a switch and a laptop, they are both nodes, right? Is through a medium, either copper, LAN cable on shielded twisted pair, or wireless. Now, wireless is part of a physical layer. Do you understand? The physical layer is responsible for moving of individual bits from one up to another up. So this layer is the one that determines the movement. Do you understand? Now, physical characteristics of the interface and medium: representation of the bits, data rate, synchronization of bits, line configuration, point-to-point or multi-point, physical topology, merge, star, ring, or bus, transmission mode, either simplex, duplex, or duplex. So what this means is that how do I communicate to the next guy? Am I sending data to you once? What simplex, duplex, and full duplex means is that when you hear simplex, it means that it's normally common with the bus topology. It means that I'm sending a data to 5 computers, right? And it's going on a straight wire, like a bus. Do you understand? Anybody that gets the data I'm sending, right? It's only one person that can have access to that data once. The rest does not have access to it. Do you understand? But a full duplex, do you understand, means that half duplex means that, oh, I can send to this one, I can send to system A, system B, and system C at the same time, right? But the difference between that's simplex and half duplex. The difference between half duplex and full duplex is that for full duplex, you can send and receive at the same time. When I send a data to someone, I can receive from that person at the same time. So the difference is speed. Yeah. Do you understand? It's speed. And that is what we have. That is what is applicable now in these days. Do you understand? That's why you can go to google.com and you'll be amazed what has happened at the back. I'll do a practical section of going to google.com and I'll tell you what has happened at the back of going to google.com. Do you understand? The communication that had happened within that space, right? So, be it wireless or wired, do you understand? The protocol that determines how a data is sent from system A to system B, do you understand, is explained within this physical layer, right? Now, physical layer, zeros and ones. I don't want to know the data you are sending. Everything boils down to zeros and ones. I'm not sure you know about hexadecimals, how it's converted to bytes, kilobytes, and gigabytes. Do you understand? How many bits make 1 byte? Do anybody know how many bits make 1 byte? Do anybody know how many bytes makes 1 kilobyte? Somebody is raising his hand.
Okay, 8 bits.
8 bits makes 1 byte. Thank you. Now, if 8 bits makes 1 byte, how many bytes makes 1 kilobyte? Somebody is raising his or her hand. Alexander.
Okay, 1024 bytes make 1 kilobyte, I believe.
Thank you. Then 1024 kilobytes makes 1 megabyte. 1024 megabytes make 1 gigabyte. Am I right? I believe I'm right. Sir. Okay, good.
Yes, you're right.
So what does that mean if you say you are sending a data of 10 gig? That means that you are converting, let me say 1 gig data, worth of data, or you're sending a movie. I don't want to care the way this stuff is, whether it's a MP3, whether it's a document, whether it's voice, whatever medium it is, do you understand? They all come down to the capacity. Do you understand? You don't worry about what breaks them down or how they're broken down. Do you understand? That's what we are talking about now. You're sending a mail from an application layer, the 7th layer of the OSI model. You go to your email and send a mail. The document you are sending is what? 10 kilobytes or 10 MB. Do you understand? That's a lot of documents. 10 MB via mail. When you send 10 MB via mail, right? You are sending 10 MB via mail. coming up, and you suddenly want to see how that is sent through the wires. What we have to do is to convert 10 kilobytes, 10 MB to kilobytes. Can we convert 10 MB to kilobytes? Is anybody with a calculator there? 10 MB to kilobyte is 10 times 10 MB to kilobyte is 10 times 1024, right? What does that give us? I need somebody to work with me. 10 times 10,024. That's 10,240, right?
Yes, sir.
Am I
Who
right?
is entering? Who is entering?
10,240. That's correct.
Okay, 10,240. 10 MB is 10,240 kilobytes. Right?
Yes, it is. Yes,
now,
sir.
How many bits is in 10,000 kilobytes? That's 10,240 times 8. Whatever.
81,920 bits, sir.
So it's 1,920 bits. Now, what does that mean is that we know bit is in zeros and ones. We all know that bit is in zeros and ones. Do you understand? So there are 89,000, whatever that is, bits. It will now, all of that will now break down from application layer to section layer to presentation layer to transport to network to data link and to physical layer, all the way to physical layer and turns to bits. Do you understand? And then go, because this is all you can have. If you know this very well, this is a circuit. 1 and 0, 1 and 0, 1 and 0. This is all the system understand. Do you understand? Through the wires. Do you understand? And then it comes all the bits through the wire and then comes here and give you this same thing. And this is encapsulation. This is encapsulation. Do you understand? So this is encoding. This is decoding. It decodes the frame and say, oh, this is so bit. And the same way it is converted to picture is converted back to what is supposed to be in the next layer, right? I've spent too much time on this. Data link layer, framing, physical addressing, low control, error control, access control. Now, what you have in data link layer is data, is frame, right? Frame. Can do a better research on that, right? So what we have here is that up to up A, we can see that this guy converted a data link, a frame to a physical layer to bits, then is sent back. If a bit is then converted to a frame, right? Let me run so that I can do a couple of practical sections so we can have a few understanding. A network layer deals with a logical address and a routing, address, majorly an IP address, right? From transport layer to network layer, it deals with packets, right? Take note of this. And source to destination delivery. Network as a packet converted to a frame, converted to bits, the other way around, right? Transport layer. This is where I tell you, one thing you have to understand about network layer is that is where the IP addressing comes in. I'll talk about IP addressing in the practical section. I'll be very fast with this mini slide and the practical section so that we can get one or two things. We have very few minutes left. This is the transport layer. The transport layer deals with segments. Do you understand? Segments. The transport layer is where you have what's it called now? TCP and UDP, right? TCP and UDP. That's what you have in the transport layer. Data coming from the upper layer have port address J, right, and K. J is the address of the sender process. and K is the address of receiving process. Since the data size is larger than the network layer can handle, the data are split into 2 packets, each packet retaining the port number J and K. Then in the network layer, network address A and B are added to the packet. I'm going to go to the first example. So look at this example now, application layer, transport layer, right? So this particular guy has J and K, right? You see this A and P is adding his own header on it. Do you understand? The IP address. So I'm adding my own that, oh, look, when you get here, look at J and K, data 2, data 1. Look at the network layer. Can you see the network layer that it has AP for data 2? It has AP for data 1 too. When it got to data link layer, he has H2. He added H2 to it. Do you understand? For data 2 and data 1 respectively. Then the physical layer converted to bits through the internet, and then it comes back here, right? And then this calculate it, and then you have T2 and T2, data 2 and data 1. You can see that it is H2 that is here. Do you understand? When it goes to network, what you have left is AP and AP. Do you understand? Then when it goes to transport layer, you have the JK and the JK. What does that mean? That means that every one of them at different section or different layer have an addition or subtraction, as it were. So this network layer, ideally, what AP that you are adding is the destination address and the source address. The MAC address, the data link layer that this with frame is talking about the MAC address. Do you understand? Let me run from here. There's a section layer. This section layer is the one that establishes a distinct connection between two. So if I send a mail, if I send a message from a Google Chrome and I say facebook.com, and I open another Google Chrome and go to google.com, the reason why I can get the right website from the web server I'm going to that particular place is because of section layer. Do you understand? So it's responsible for dialogue control and synchronization. It establishes, maintain, and synchronize the interaction between communication system, right? Presentation layer is responsible for encryption, right? Is responsible for encryption. And then application layer, that is where you have your applications, your mail server, your file transfer, your HTTPS, those are applications, right? I'm going to run through a summary of this. What is application layer? It to allow access to network resources, right, on application layer. Presentation layer translates, encrypts, and compress data. Section layer to establish, manage, and terminate section. So if I close a tab, I've closed that section, right? Transport to provide reliable process-to-process message delivery and error recovery, right? There are 2 types of transport protocol, TCP and UDP. TCP does 3 handshake, which is windowing. I'm going to send, you're going to acknowledge. I'm going to send, you're going to acknowledge. So for TCP, the message is reliable. You will get my mail. Do you understand? Because there's an acknowledgement that, oh, I'm sending through TCP. But UDP, there's no way you can get, I've sent it to, whether you receive it or you don't receive it, it's none of my business. Me, I shall send it. Do you understand? That is UDP. And wire network, to move packet from source to destination to provide internetworking. So the source IP address and destination IP address. Data link organize bits into frame. To organize bits into frame to provide up-to-up delivery, right? So it turns frame to bits. from the sending part, and then send bits back to frame from the receiving part. You know, there are two parts to it, from system A and system B. Then physical layer to transmit bits over a medium, bits. That is what physical layer does with, to provide mechanical and electrical specification, right? These guys have come up with this layer so that you can have a thorough look at different section or different layer and say, oh, this is what happens here, right? You don't need to worry about if you don't understand to some extent all of this. What is important is that you understand OSI model. You know what it means. Do you understand? You will now start learning the protocols that happens in each of these, because this is elementary, right? And I feel like I'm even going beyond the elementary right now. Okay, so this is pretty much what I've said. Sender and receiver, user support layer, data. Do you understand? Segments, packet, frame, and bit. Don't forget, it is still in data form at application, presentation, and section layers. Once you get to transport layer, it becomes segment, end-to-end connection reliability. Is it going to be safe or not safe? Is it going to be TCP or UDP? Packet, network, where am I sending it to? I need an address. What is the IP address? I will tell you for free, any site you go to has an IP address. It is the domain name server that makes you not see the IP address. Then the frame, data link, a physical address, that is your MAC address. And the frame turns it to bits, which is the physical bits, right? And then, I think that's the last part of it, right? I'm going to stop sharing this particular slide, and I'm going to take the next 10 minutes. I'm going to take the next 10 minutes to take a couple of practical sections. Is that all right? Can somebody give me, while I open my practical section, I want somebody to tell me what he or she understands by OSI model. Just in 1 minute, say something about OSI model if you can. Please just raise your mic, raise your hands, and Sheila will call you.
Okay, I don't know if I can speak now.
Yes, you can speak, please. Folashade, is that Folashade? I can see Folashade Banire. Or is that another person?
No, it's in Abitech.
Abitech, please, you can speak.
Okay, OSI model. OSI model is like a standard. It is a standardized model for each product the manufacturer to integrate so that there will be easy communication between two computers. For example, if there was no OSI model, Mac OS for the Apple product would have a model they design their own system. Windows will also do something slightly different, and that will make the two products not easily integrate or not easily communicate together. But with the OSI model, they can easily interact online. They can easily communicate via network, understanding that is speaking one language.
Very true. Very true. So I like the fact that you are coming from a vendor perspective, right? So that means that, right, a Mac laptop and the normal Windows laptop, right, they can both go through the same process. So that is the reason why I can browse on a laptop, on my Windows laptop, and browse on my Mac laptop, because either you like it or not, it's still RJ45 or wireless. The physical layer is either a wired or a wireless port. Do you understand? I'm still going to connect, and then the data I send will still be converted to a frame, It's still going to go to a network. I need an IP address for network layer. I don't want to know what kind of system it is. If you don't comply with the fact that they have to be, you will not be, be able to connect it to the network. Do you understand? And the same thing applies. You can come up with your own design, but you still have to follow through these protocols and this layer. So that's one of the distinct, reason why you have OSI model. Yes, thank you, IBTech. Any other person? So this is Packet Tracer. I'm sure some of you have heard about Packet Tracer. I've seen it before or something. Ew. Please don't tell me that I can't share my Packet Tracer screen. Fola, can I hear from you?
All right, good evening. Can you hear me?
Yes.
Okay, so what I understand about the OSI layer is we have 7 layers.
Yeah.
And most times it starts from the application layer. It comes from the bottom to the up. I'm not sure if that is right, or up to the bottom. But anyway, it starts from where we have a user sends a request for probably a web, then it goes down to it gets to the physical layer. But I understand that physical layer has to do with the physical what's it called? The physical network things that we can use coming from our wireless to our wired cable, like the connections. Then our network is transferred from each layer till it gets to the sender, and all of this happen within milliseconds. So that's what I understand.
Thank you so much for that, Shadi. That's pretty much what it means. I won't call any other person. Please allow me. Forgive me, rather. So that we can have a couple of minutes on this before we go to question and answer. So if you can, if you want to, you can go to cisco.com, create an account there. There are different courses you can take for free on networking, and you can have access to Cisco Packet Tracer for free, and you can do, that is the beauty of networking. All of this we are talking about, you see it real life. And everything you see on the Cisco Packet Tracer, they are simulations, but this is exactly what you can do on a real life, right? I'm not going to go into configuration, how to configure a router, a switch. That is probably advanced, but I'll show you some of these devices. Now, this is network devices, right? This is end devices. I'm going to take a laptop. I'm going to a PC. I'm going to take a laptop. I'm going to take a server, right? I'm going to take I'm not going to work with a hub because you barely have hub these days. I'm going to take a switch, right? And I'm going to take a wireless access, a wireless LAN, do you understand? And of course, I might as well take a couple of wireless devices. Please, can you see my screen?
Yes,
Yes,
yes.
Sir. Yes.
Okay. Okay. So I'll take 2 smartphones. I'm going to, Sheila, please allow me. I'm going to eat into the question and answer time a bit, maybe for 10 minutes, because this is actually very essential to the training, if that's allowed.
All right, no problem, no problem.
All right. So I've talked about topology, right? So topology is the design of your network. So a typical bus topology, right, will be this. I hope I can run this in a few minutes. Control C, Control V, Control V, Control V. Don't worry about all you see here. Yeah. So when all of these guys are connected on a straight line, that is the bus topology, right? That is the bus topology. A merge topology is majorly when there's redundancy. This guy, talking about our nodes, these are nodes, right? These are different nodes: system, smartphone, wireless LAN, another smartphone, server, switch. Let me get a router, right? This is a router, another nodes. So we understand what nodes means exactly, right? So the medium of communication, right? So this is, if I come here, can you see that this is a console? A console is a cable that connects a system to a router for the first time. You connect to the console so that you can start an initial configuration, right? This is a copper straight through. There are two types of there's crossover and then straight through. Straight through connects two different devices together. When you're connecting the same kind of device together, you use a crossover. They are still both copper, the UDP cable that we spoke about, the normal LAN cable. But the way the connector mount is set is different. The color code of the mount is different. Do you understand? That's the difference. But normally, when you go to the market, I want a straight through cable. Do you understand? A straight through cable connects two different devices together. A switch to a system, a switch to a router, straight through, right? And this is a crossover cable. Can you see where my mouse is? And can you see the crossover under it?
Yes, yes, we can see it.
Good. Now, this is a fiber optics cable. We spoke about it. This is a phone cable. This is a coaxial cable. That's the T-net, thicknet, or whatever it is. This is a serial cable. Do you understand? Octa cable, IoT custom cable, USB cable, right? So those are the cable. But what kind of cable are we using to connect from this switch to this PC? From this switch to this PC, what kind of cable are we using? What kind of cable are we using, please? I need someone to answer.
From what? What did you say?
From a switch to a PC, what kind of cable are we using? Is it a straight through or crossover?
I'm using straight through.
Thank you. So I'm connecting to the first port of this cable, and I'm connecting to this system, right? What have I established here? I'm going to do a star topology because that is the most common one. I'm going to connect from this system again to the second cable. From this third system to the third port. From the fourth system to the fourth port. And I'm going to connect from the fifth port here to the router. Do you understand? Now, this router is supposed to take me to the internet. Do you understand? Okay, I'm going to work on that later because of time. Now, so what are the things you need? Okay, just for wireless sake, I'm going to connect to this guy. Do you understand? And I'm going to take this wireless device over here and connect them to my network. These things are supposed to be plug and play. I don't know why it's not connecting to them.
Sorry, please, who is IJ? Kindly mute your microphone, please. Toby, can you bring your hand down? Thank you.
Okay, so exactly the device I'm looking for. So this is an access point, right? I'm going to connect it to the network too. I'm not going to use the port 10 because it's a wireless network, just to be different from the others. So does this make any sense to you? Does this make any sense to you? So
Yes.
these are nodes.
Yes, it does.
And access points. There's only an access point that can communicate to this guy. Every wireless network is connected to a wired network, one point to the other. Do you understand? So what I'm trying to achieve here is to see if you can run through the OSI model, right? Just in a few minutes. Now, the first point is what? The bits. I didn't talk about IP addressing, and you have to do a thorough research on IP addressing. It's a class on its own. So just on the rundown, what is IP addressing? IP address is a logical IP address that is assigned to a system, right? Every system has its own inbuilt address, which is a MAC address. For example, on this particular system, if I come to the desktop of this system, you can do this on your personal system. I do IP config, right? I'm going to do /all to show all the NIC. We talk about NIC, right? Network interface card. So the first internet network interface card of this particular system is saying that the physical address is this. The link local IPv6 address. We're not talking about IPv6. That one is another scope entirely. We are talking about there are two types of IP address, version 6 and version 4, right? So the version 4 IP address is 0, subnet is 0, gateway is 0. Do you understand? And you cannot go anywhere except you have an IP address and where you are going to. You can't tell me you want to send a mail to someone and you don't put the address. You are sending a mail via courier to someone and you not put the address. It's not going to go anywhere. You have to put your own address and the person's address so that if they are sending it back or there's a failure somewhere. So that is what physical address is all about. So I'm saying I want to go from this guy to this guy or from this guy to this guy. How can I make this journey, right? You have to have a proper IP address scheme. Do you understand? Within a network, an IP address that works within a network is called private IP address, and it's two sets. It is 192. Class A, Class B, Class C private IP address. The Class A is 10.0.0 to 10.255.255.255, while the Class B is 17.16.0.0 to 17.16.255.255.255, 17.16.0.0 to 17.16.255.255. The Class B is 192.168.0.0 to 192.168.255.245. I'm sure you are very familiar with that. So we'll go with Class C. So example, I'm setting an IP address on this guy, right? IP configuration. I'm not using DHCP, I'm using a static IP address, and I'm giving this guy 192.168.2. This is 2.3. I'll make this guy system. Let me start with 20. Do you understand? So subnet mask. I'm not going to assign a default gateway because we are not going within this local network. And I'm going to give this guy configuration ipconfig, and this is about the last one, 192.168. What did I use for the other one? Two dot 20. So I'll do 2.21. 192.168.2.21. All right, so I'll just stop there. So this is the part for IP version 6, but that's beyond the scope. Let's just stay here. I didn't say much about the IP address. It's under the network layer, right? You have to do a thorough research study on that, and there are a lot of materials online you can use to have. So I'm going to send a communication from this guy to this guy. The first thing I want to do is I want to check my IP address. I'm going to do that. I've done it here before. I'm going to do that command again, just to know my IP address. So if you notice now that my IP address is what? .2.21, right? So I'm going to ping. Ping is ICMP and is a protocol under data link layer. Yeah, do you understand? Ping is used to test network, right? So I'm going to ping first myself, 192.168. What's my IP address? 2.21, right? You can see that reply. You can see what is replying, right? And I'm going to do .20, which is the next guy beside me. You can see that they can communicate to each other. Now, to see if we want to, I'm going to there's something I'm looking for, simulations, right? And I'm going to send in a form of a mail coming on. Just a minute. Something blocking my. Yeah. So I'm sending a mail from this guy to this guy, right? So I want you to watch as this play out. Okay, so can you see my screen? So you can see that this is a bit advanced, and I'm just going to stop on this very soon. The OSI model, right? layer 7, layer 6, layer 5, layer 4, layer 3. Okay. So I'm going to play this now. So this layer 1, 40/3 received the frame. The frame source MAC address was found in MAC table. Do you understand? Of switch. This unicast frame switch looks in its MAC table for destination MAC address, right? The outgoing port is an access port. Switch send the frame out that port. Fast Ethernet 02 send out the frame. Do you understand? Now, the reason why it stopped as frame level, do you understand, is because it's on the switch level. If you are working on a network layer, you would have talked about what's it called? You would have seen the whole thing played out, but there's no time for that. If you are moving from one network to another level, you would have seen level 7, level 6, level 5, level 4, level 3, how everything is played out, right? So I will stop here for question's sake, right? Because I don't want to overwhelm you. For some people that this is the first time they're having this network training, so that it will not be like, this is not something I want to ever do in my life. I'm not interested. Do you understand? You cannot be a security person without understanding the basics of network. You can't protect what you don't know, right? You can't protect. And that's why I'm taking it from this perspective. I'm trying to go into the depth of the elementary so that if you understand these things, you understand where to protect. There are security protection or measures that you have to take in each of these layers, all right, as time goes on. You understand that better. Well, I hope I've been able to communicate one or two things to everyone and not to overwhelm you with unnecessary details. So I will just give the floor back to Sheila to coordinate the question and answer. I'm so sorry I took extra 15 minutes for the question from the question and answer, but I believe this would have blessed you more. And if you want to do some personal training on this, you can make use of Packet Tracer, right? So over to you, Sheila.
Okay, so Sheila is on this call. I guess she's been kicked out. Thank you very much, Olufemi. We are grateful. All right, some person says they are lost. I understand. You must be lost. If you are not lost, I'll be surprised. So if you're lost, just take it easy on yourself. You are not supposed to know it for one day. So the only way you cannot be lost is if you try to rewatch this video, or perhaps you look up other videos on YouTube and then try download them. The Packet Tracer for yourself and start practicing, and it will become more clearer to you. Because if you want to understand this thing for once, you might crash. You might crash. You just hear your OS will just be removing smoke. Okay, so I think Kayode, please coordinate the questions. But Femi, thank you very much for this insightful lecture. It's very amazing. It's on Windows. I don't know if you can run it on Linux, but it's not necessary to be run on Linux. You can just run it on Windows. It's just a network simulation application or software rather. So it's just a very simple thing. Just go to skillsforall.com or cisco.com and then you see it there. Just download it. It works on both mobile and then on Windows. You can use it both on mobile and then on desktop. Okay, I'm not sure Kayode is on this call as well. Please, if you have any question, please raise your hand. We have less than 11 minutes to do this, so everybody can run and go back to their day business. If you have questions, please signify with a show of hand. Any question? Any question? Any question? Yeah, empty and do strong thing. We are sorry. Any question?